today's learning targets, I can find asymptotes by using limits. We did this in pre-calc, those of you that were in pre-calc before last year. I can explain the connection between asymptotes and limits. All right, well, we're going to use limits to find them, so there's a connection there. So let's, that's okay. I thought it was one of them at first. Use. All right, so finite limits. Finite is the opposite of infinite. So finite means it doesn't open. Okay, as x approaches positive and negative infinity. All right, let's take a look at this. We have a function as f of x approaches b when I put positive infinity for x versus negative infinity of x. All right. That is how you find your horizontal asymptotes. All right? If you plug in infinity or negative infinity and you get a value like 6 or 2 or 1/2, that means you have a horizontal asymptote at that 6 or that 2 or that 1/2. Meaning, if I plug infinity in here and it ends up being 7, and plug negative infinity at 7 or whatever, that means I have an asymptote at y equals 7. Whatever number that is. Do you remember, you guys that were not in my pre-calc class last year might not know this, but when we plug infinity in using a limit, like let's say it's a fraction or an expression, what do we do? Do you remember? No? There are a couple different ways to do this. You can plug positive and negative infinity into x and evaluate. All right? You can reference your graph as you go up forever, because remember, that's your x value. You just keep on going up forever. Eventually, it's going to approach something. And then that's positive infinity. You can go down forever. Okay, on your x value for your table, and you'll eventually get, it'll approach a value. It'll approach a y value. And those will be your things. The things. The asymptotes. Now, I have a better way to find the vertical limits. Okay, here in the book it says, when you plug in a number and you approach it from the right side and approach it from the left side, if you get positive and negative infinity, then that's a vertical asymptote there. For me, it's just what value makes x undefined. If there's a value that makes x undefined, there's either an asymptote or a hole in the graph. To me, that's a lot easier to do. But ultimately, all right, I would reference my graph or my table every time I start my graph. That top bullet, what value of x makes the function undefined, that's a nice one. You can do it on the graph. Otherwise, look at your graph. Life is easier that way. Okay. So let's find all vertical and horizontal asymptotes using limits for the function here. That's what I'm going to do. We have horizontal and vertical. For my horizontal, okay, that's when I take the limits as x approaches infinity of my function, 1 over x. All I do is I plug infinity in for my x. So that's 1 over infinity. What happens to a fraction when the top's in the same but the bottom gets bigger and bigger and bigger? The overall value gets smaller and smaller and smaller. For example, 1 over 1. 1 over 1, that's 1. You don't have to write this part down. What happens if I just increase the bottom? 0.5. I increase it again to 0.25, and just gets smaller and smaller. Now, what if I go an extremely large value in the bottom? 1 over a million. 1 over 10 million. It's going to get so small, it looks like
nothing.
Nothing. It looks like 0. Looks like 0. So, they want you to try the positive and the negative infinity. So then again, I go the limits as x approaches negative infinity of 1 over x. Well, that's 1 over negative infinity. That's still going to approach 0. So guess where I have a horizontal asymptote? At what equals 0? Y equals 0. Because y equals a number, that's a horizontal line. So there is a horizontal asymptote at y equals 0. All right? Not too difficult. Not too crazy. What's a big vertical? Now I said we can throw in a number that makes it look what makes that function undefined? What value of x makes that function undefined? 0. That's where your vertical asymptote is. That's the way I do it. So in order to make 1 over x undefined, the bottom has to equal 0, doesn't it?
Yeah.
In this case, I've solved it. X is equal to 0. It was x plus 2 equals 0 when I just subtract 2 from both sides. That's where your vertical asymptote is. So when everything's all said and done, and I don't know what this graph is going to look like. I mean, I do, but we haven't seen it yet. I'm going to have a set of axes here, and I'm going to have a horizontal asymptote at y equals 0. Now we have a vertical asymptote at x equals 0. And I don't know what the graph's going to do. I mean, maybe it goes like this and like this. It's probably going to do something like that. So we put it in C.
Yeah, it's like an hourglass.
Perhaps.
Whoa.
So I'm going to y equals, I'm going to say that is, yeah, 1 over x, right? Let's grab that bad boy. Oh my God, it's exactly what we said it would do. In fact, let's go to the window and make it even better. Minus 5 over 5. Minus 5 over 5. Oh my God, go to.
Oh, it's going to say gato. It's going to say what?
El gato.
Yeah. Gato.
Now you can kind of see it a little bit better as you zoomed in. And that's exactly how we said it would look like, isn't it? It is. Look at us. And there is a horizontal asymptote here that it doesn't touch at y equals 0, and a vertical asymptote at x equals 0. So you see how you just like look at the graph and see what the proof is happening there? All right. Why don't you try this one? Okay? Find all vertical and horizontal asymptotes using limits for the function f of x equals 2 plus 1 over x. Now keep in mind, for vertical asymptotes, you can kind of just figure out what makes what undefined. All right? Good luck. Bam. All right, we are going to do the horizontal limits first, because those are where I am plugging in the positive and negative infinities. So I'm going to say the limit as x approaches infinity of 2 plus 1 over x. Well, I'm just going to plug infinity in there. So that is 2 plus 1 over infinity. And what does 1 over infinity approach? That's like 2 plus 0. So what's my answer? 2. Let's check negative infinity. I think you realize it should be the same thing, right? 2 plus 1 over x. Oh, yeah. That's like 2 plus 1 over negative infinity, which still approaches 0. And that is also 2. So, there is a horizontal asymptote at y equals d. All right? Not crazy. Nope. Not yet, anyway. Now, if I have 2 plus 1 over x, how does that become undefined? Well, you can't make this undefined. You would have to make this expression undefined, right? So 1 over x would have to be undefined, which means the bottom would have to equal 0. But that would be undefined, wouldn't it?
I knew that.
That's your vertical asymptote. So let's, you don't get rid of it. You focus on what makes this undefined. The only thing that would make this undefined is if you had a 0 down here. Could you add an undefined value to 2, then it's undefined. If I didn't have this fraction here, I can't make 2 undefined. There would be no vertical asymptote, would there? Because nothing would make 2 undefined, would it? Okay, let me re-explain this. The vertical. What makes 2 plus 1 over x undefined? What's the only thing that can be undefined there? 0 on the bottom. 1x is 0. There you go. There's your vertical asymptote. Don't overcomplicate it. So if I graph this, where y is equal to 2, that's going to be my horizontal asymptote. Where x is equal to 0, that's my horizontal asymptote. Okay? So I might have something that looks like that, maybe. Maybe. Should we plug it in the calculator and see? What? Vertical is which value of x makes it undefined. That is what value of x makes it undefined. We will continue this tomorrow.
Okay.